Hi, everybody. Kevin here. We're going to do some programming today. I did a big blog post a while ago about um, it was sort of just a basic guide on how to make a physics system in a game, one that's kind of human understandable that works in Game Maker. Um, and I explained it, but I didn't really show a lot of code because the idea was more important. But um, what I'm going to do is I'm just going to write the system out now, and I'm going to walk you through my process. The first time I started making games, it took me about a year to really like nail down the physics system, and then I wrote it again in a month, and then for a smaller project. That was actually if you played Plasma Skeletons, that was my first rewrite of the physics system that I used in Project Maiden. And then just as like a practice thing for every jam, I would like rewrite the system to like kind of get it better. And those same basic ideas are what I use in Bazooka Panic. So I'm going to see. I reviewed what I have going on in Bazooka Panic, and it's a little more complicated than what I'm going to write today. Um, but yeah, Hootie's might be helping me, might be coming and going, and we're just gonna figure it out today. All right, so we have a new Game Maker project. There's nothing here. This is kind of a little personal challenge for me to see if I can remember how to write my own physics system from the top of my head. I think I can. So we're gonna make some sprites. This is going to be sprite character. These are actually going to be masks. So I use a one-letter designator on my stuff. M is for mask. And we'll make this. I usually work in 12 by 12 sprites, so we'll just make this a 12 by 12 sprite because that's nice and chunky. And we'll make it red, and we'll show kind of where the corners are and where the middle bit is. And that is our character sprite. And then we'll duplicate that and we'll make a walls mask. So sprites and masks are the same thing in Game Maker. If this is usually the shape I do for walls. I just do a black block with a white outline inside. Sprites and masks are the same thing. When you check collisions, you set a sprite as something's collision mask. I always have walls be in the top left corner, just 0, 0. Okay, so we have we're gonna need a wall object and a character object, so the character can impact with the wall. That's what physics is in game lingo. It's just how do two objects interact. So we're going to do p wall. I use p to designate parents. Usually, if I want a thing to affect a bunch of different things, I have the parent, and then I'll just call it parent for whatever. So this will be parent wall, and this will be O character, O for object. And there we go. I don't have to really write any code for the wall, but we'll also make a room. We can leave this as room 0. If we're doing 12 by 12, we can go 144 by 144 and set the snap there. Since this is just our test room, we can set the speed in here. And that'll be good. We can fill the test room with our walls. Just kind of wall it in like that. And then we'll do a few other walls. This is reminding me that I should probably make my character sprite a little smaller than my walls. Just so it's a little more negotiable. Did I hear a meow? Okay. And there we go. That's our first room. Check. So whatever room's first, GameMaker's gonna load that. All right. So now we have character, we have walls. Time to make them interact. So let's write some scripts. You can do this in the character or wall code. Obviously, I'm going to apply this movement stuff to a lot of different things. So I want to make sure I'm not repeating myself anywhere. So I'm going to do it mostly in scripts. We're going to have 3 scripts, and I'll try and how do I make the text? How do I make the text as big as possible? Because I want you guys to see it. F8. Okay, so okay, big text. Okay, so this script is going to be I use X to denote scripts, so this is X move. It's going to be a thing that we run to move a character for now. Maybe we'll use it to move a wall later. Maybe we'll use it to move an enemy. So we have one script called X move. We're gonna have another script. We're gonna call it V move. This is where all the variables a thing needs to move will be kept. When we create an object, we'll run V move, and then it'll know what those things mean for X move. So in V move, I'm going to add 2 variables. GameMaker has its own physics system inside it, which I don't like to use because it tends to cause problems, and I don't know how to fix those problems when they work because I didn't write that physics code. So things like hspeed, which would be a really useful variable name, otherwise I can't use because it's already tied to the GameMaker physics system, and that's why it's in red right here. So to denote what horizontal speed is, I'm just going to call that go horizontal. That's how I tell things to go horizontal. If it's negative, it's going to go to the left. If it's positive, it's going to go to the right. So go horizontal is going to be 0. Go vertical is going to be 0. This is just initiating those variables. Other things I want, we're going to have a variable called xhold and yhold. We're going to be moving our object 1 pixel at a time, and we don't want any we don't want the positioning to be off by like a decimal place, because that's going to make things more complicated. But we want to save that decimal place so that we can do more variable speeds rather than keeping exactly to like 1 pixel at a time or 2 pixels at a time. If we want like half a pixel at a time of movement, we want to be able to do that. So we're just going to keep our little remainders in a bucket, and then we can apply those later. Other things we need in this, I'm sure I'll think of them as I start writing the code. So first thing we're going to do when we start this code is we're going to declare a few temporary variables. We're going to call the first one move h, and the second one move v. Move horizontal, move vertical. This is what we'll actually use to move. So what we're going to do with this is we're going to set some stuff up. So this is going to be argument based. This is a new thing I'm doing, is instead of just automatically doing move h equals go or whatever, it's actually going to be equal to an argument. This is going to be useful later. So when we write the script, we can put in 2 different variables. If we want to do moving platforms, this helps a lot. If we just wanted to nudge something by 1 pixel, this helps a lot. So we're just gonna do this argument based, but in every frame, we're essentially gonna plug in go and gov, and that's gonna help us. Yeah. Okay. So argument 0, argument 1, and nice. Next thing we need to do is we need to get the fractions of these variables. So we're going to write a script called dfrac. This is just the thing I do. So this takes a this takes a variable and just gives me the fraction part of that variable. So how do I do this again? I think I do return argument 0. So you put in a thing minus frac. Yeah, okay. So frac gives me the fraction. Got it. Okay, yep. Okay, yeah, okay. So defrac, I'm remembering things now. What defrac does is it gives us the number we put into it minus everything after the decimal place. So that is useful for us figuring out how far we're moving a thing. Frac is good because defrac is necessary as a script because when you round or floor something, it's different depending on if the thing is positive or negative. Defrac is just going to give us a number minus everything after the decimal place, so it's just everything before the decimal place. So that's defrac. Cool. Okay, so we've got our move variables. So we're going to make move h actual move v actual. Okay. Some further elements to this. Okay. So we're going to put in two things that might have fractions at the end of them, and we're going to augment that a little bit. So first up, we're going to declare move h actual to be no, actually we have to get the x holds after this. So x hold is going to be incremented by move h by a fraction of move h. Okay. Okay. Neat. Yep. Okay, so basically we're taking the stuff after the decimal place and we're adding it to this hold value. This will be a lot more clear if you read my post on everything. I'm kind of trying to remember the stuff I do as a personal challenge, so this may or may not be helpful and maybe a little rambly, so I'm sorry. But okay, so we're slicing off these fractions and adding them to our fraction bucket. Then we're going to figure out how much we're actually moving. So move h actual is going to be defrac. Yeah. Of move h. And then plus the defrac of x hold. Yeah. So if x hold is bumped up to like a 1 or a -1, it's going to affect how much we're moving in this. So good. Good. We'll do the same for the y side of this. And then we're going to set x hold to the fraction of itself, since we've already gotten the number where we want to move out of this. So we shouldn't be moving by more than 1 with all this, but this just keeps it correct. And okay, we are almost ready to move a thing. We don't have to worry about the x holds and y holds anymore. We just have to worry about move h actual. So first thing we're going to do is we're going to set up a little thing to save time. So if there's no place meeting, x plus move h, y plus move v, p wall. Okay, so if there's no collision in the place we want to move with a wall, then we just do x plus move h, y plus move v, and that's it. Otherwise, we have things we have to do. Right, Houdini? You helping? Okay. So the thing we have to do is move. So if there's no collision, fine, we just move it right to where we want to go. If there is a collision, we move it step by step until we find out where the collision is. There are ways you can do this easier. Like you could test it like half a step at a time to save those little beats. But I make all my games with really, really chunky pixel graphics. So I don't necessarily have to worry about that so much. Everything I do tends to run pretty fine, even in like HTML5 or on bad machines, because I use crappy, outdated software, very beige software. So yeah, we're just gonna do this the regular way. So what we're gonna do is we're gonna get a few more variables. So we want move v deer and move h deer. Okay. Gonna get that, and we're gonna get move v deer, and that's gonna be equal to the sign of move h actual, and this is going to be equal to the sign of move v actual. So this is going to tell us, so this just grabs the sign. So if it's positive, negative, or 0, then we can do this. So we repeat. We'll do repeat for now. I might change this up in a sec. But this is an easy way to understand it. So first we'll move horizontally, and you can like switch this up so it moves in like a more diagonal way. It doesn't really matter if you're only moving like, I think the most a thing will be moving will be like 5 pixels if it's going really fast, moving 5 pixels a frame. But so if you're moving like a really far way, you could like kind of divide it up into different steps and kind of move in a more jagged way. But we're essentially going to move all the way horizontal first and then move all the way vertical next. So we're going to repeat move h actual, and if that's equal to 0, then fine. Yeah, this is going to change to a while loop in a second, I'm realizing. Okay, but whatever. If we're going to have another place meeting, so we'll just grab this. So if there's a place meeting, x plus moved here, p wall, then we want to end that repeat, so we can make that like a while or something like that. So we'll just put a note here, like we don't want to do anything there. You can also like write code there to like make a thing bounce or something like that, but this is just the simplest version of this code. Else what else? Oh, yeah, okay. So otherwise x plus Okay. So we need another one. And this is going to be called move dex. Move dex is going to be equal to 0. Then we'll increment move dex plus 1. Okay. So I add a new variable. It's move dex. It's going to tell us how many times we've run this move thing. We're going to change this repeat to a while. And this is going to be while the absolute value. So removing the positive or negative of move h, which I should have done for the repeat anyway, but whatever. Okay, so while this is greater than move dex, do this. Cool. So this will also let us turn this off, because when we meet a place we want to stop moving, and we'll also set our go. So we will reference we will reference our speed here, because when we hit a thing, when we hit a wall, we want to stop moving. So this is the variable that we plug in to tell our dude to move. So we need that. So this tells our dude to stop moving because they've hit a wall. This tells our script to stop happening because it's over. Cool. And that'll cause our while loop to stop repeating. And that is basically, I think that's it. Okay, so then we just do this again, but vertically. So we copy this, we go down, and we reset move dex. We want move v, go vertical, move v deer, and move dex is fine. V. Okay. I didn't need to count the last V. Okay, that might be it. We just need to do one more thing to fix stuff at the end, and then we can kind of set this up. So this is all the code. It's about 50 lines, and here's what it actually does. Okay, so we start off, and we pass in these variables because that'll be helpful later. But these are essentially going to be our go horizontal and our go vertical variables. Then we increment x hold by our fraction. So that's us putting our fractions in a bucket. Then our the actual amount we move is equal to our movement value that we're using without the fraction, because we added that to the bucket, plus our bucketed value if it's bigger than if it's 1 or bigger, or -1 or smaller. So that just sort of gets all of our rounding stuff together. Then we can remove all the stuff, all the overflow from the bucket essentially in this, and we're cleaned up for where we're going. Then next up, we are asking if there's a place meeting or a collision to the point where we will end up with, to the point where we'll end if we just go where we want to go. So is anything in the end zone where we're trying to go? And if the answer is no, then we'll just move there. We don't have to do all these extra checks. But if there is an obstruction in the place where we want to end, then we should run some code. So first we'll figure out which direction we're moving, both horizontally and vertically. Then for the horizontal movement, we'll start counting how many times we do this step, but while the absolute value of our movement, so the maximum value, is greater than move dex, the number of times we've moved. So if for some reason we're not moving horizontally this turn, we're moving vertically, that'll just be 0, and 0 is not bigger than 0, so we'll skip. But then, however many times we end up going through this, if there's a collision where in the next pixel over where we're going horizontally, we will stop moving. Our go will become 0. Our go horizontal will become 0. And then this will tell this while loop to stop going because 0 is not bigger than anything. And then we'll increment, and then otherwise, if there's nothing blocking our path, the obstruction that we detected up here is somewhere else. We'll just move 1 pixel over and start going down the line again. And then we do the same thing vertically. Yeah, that's the code. We're going to hit good. And we're going to set this up. So the next thing we're going to need to do is the character's going to have to walk around to show that we can move at all. So we'll just do some really basic keyboard code. So if keyboard check virtual keyboard left. So if we're hitting left, then go horizontal is going to be equal to, let's say, 2.5. Or we can just set a speed variable up here. And we'll say mspeed is 2.5. And this isn't how I write it, but we're going for speed. So if it's going positively, then it's going to the right. So we want this to be negative m speed. So negative m speed. And then this will be going to the right. VK right. Else we can just stop. In an actual video game, you might want some acceleration or something there, but again, we're going for speed here, and then we'll do the same thing vertically. So this would be up, this would be down, this would be go vertical, go vertical, go vertical. Okay, so that's our walk code, and now we just have to put all this stuff into our character. Add event. Create, add event, step, and then we'll do all of our physics stuff on the end step. So first things first, we're gonna run our move variables so it knows all those things it needs to keep track of. We're going to run our character move script. They call it character move? Character walk. We're going to run our walking script so that we can walk around and see that our physics are indeed working. And then in this last one, we're going to run xmove. We're going to execute the move script, which has all of the stuff we just wrote in it. Okay, so we're going to look at our room again. We also should have been saving a lot more than we've been doing. We're going to look at our move again. We're going to get our character. We're going to drop him in. It's fine that he's, yeah, I centered him, so we don't want to put him on anything bad, but okay. So we've got our character, we've got our room. We're going to go. We're going to compile it. Xmove expects 2 arguments. That's right. Okay, yeah, I wrote it differently than I normally do. Okay. Let's do go. All right, yep. That's what we wanted to do. And we're just going to change a few GameMaker settings because I think it's going to have anti-aliasing on. Don't interpolate colors between pixels. Allow the player to resize the game window. Yeah, fine, good. We want those crisp pixels for our. Oh, we get the GameMaker splash screen. Forgot to turn that off too. Okay. And here we go. So if I hit left, I go left. If I hit right, I go right. Nice. Neat. Oh, we can see some stuttering. Interesting. Wonder why it's doing that. Ooh. So not without problems, but still pretty cool. Yeah. Oh, this might be yeah, there might be one or two more lines of code we gotta add in there. Interesting. Why am I going up? Oh, I think I forgot to let's go back and look at the code. So over in Xmove. So there's something wrong with the horizontal move. Oh, because I'm making it. I'm dumb. Okay, so that should be place meeting x y plus move v dir, and this should be y plus move dir. Cool. Yep. Things can get a little complicated, but basically I just copy pasted this all over, not realizing that I was checking on the x coordinate when I should have been checking on the y coordinate, and I was incrementing the x coordinate when I should have been incrementing the y coordinate. This is what happens when you move fast. You miss things, but this is also why we test our code, and we don't just trust our brain to tell the computer what to do. We have that beautiful Game Maker splash screen yet again. Okay, now it should be perfect. Yeah. But you see, I could fix that problem because I can keep that physics code in my brain. And things become a problem when you don't know how the stuff you're using works. So, I don't know. This is the way I like to do it. Yeah. We go right up there, and we don't get any problems. Now we can do crazy stuff like if we want, we can make it so we move like crazy fast. Like we'll turn m speed to 25 instead of 2.5, and then we'll make it so we move like crazy slow. So we'll go really fast horizontally and like really slow vertically. So that's what this will look like. So this is just to show off that this is gonna work no matter what values you plug in. So boom, wait. So boom. So yeah. And if I hold this, I should move up eventually, right? 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 Why isn't that moving? Let's see why that's not moving. And speed equals 0.25. Is that just too slow? It shouldn't be too slow. Speed goes. Let's see why this isn't working. So this should be moving me 1 pixel every 4 steps. We'll set. We know the fast works. Let's see if the slow works. Okay, slow is in fact not working currently. And I wonder if it's because of how I'm bucketing things. That might have another programming connotation. I'm sorry, actual programmers who are watching this. Okay. Told is a fraction of move h, so we increment that by that. Yep. Move h actual equals defrac move h plus defrac x hold. Yeah. Oh, I want x hold to reset itself to a fraction of itself. So okay, that was the issue there. So now this should work. Yeah, now we're moving slow. Look at that thing. So precise. All right. Neat. We've proven we can go fast. We've proven we can go slow. Um, we've more or less debugged our speedily written kind of crappy code. Um, yeah, that might be all the things. I guess we can do like uh, let's see what happens when we move a random amount every turn and see if that breaks anything. It shouldn't. It shouldn't at this point, but it's good to just test various things. Yeah, so we kind of get a weird move pattern with this, but we still move. Like a weird kind of sluggy crawling move pattern, as it can't really... It's just kind of moving how the randomness determines it. Okay, yeah. But, you know, we're not colliding on any walls. And things are going fine. That's basically it. That's how I do my code for physics in basically all of my games that require an action component. This isn't how I do it for roguelikes that are on a grid and turn-based. That doesn't need constant physics updates or anything like that. That just needs a single check from square to square. But this is how I do it for Bazooka Panic, for Blink Blanc, for basically all my games. Ushanka, Eliezer, all my games that require movement. And then, like, you know, from this, like, this is the top down, like, this is how it moves top down. I can add gravity, and then that'll make it a platformer. Yeah, but there we go. That's physics. I don't know how long I've been going. I hope I didn't take up too much of your time. Hopefully I can solve that in editing. Almost 40 minutes. Okay. I will edit this, and we'll see. We'll see if I can cut things down a little bit. But yeah, thank you for watching all of this. If you did, that's very nice of you. And good luck if you're making games. If you have any things you want me to make a video about, send me a message. If you have any questions about game development that a dummy like me could answer, then I'd be glad to. But yeah, thank you for supporting me. If you did, if you'd like to support me, but you're not currently yet, check out givekevinmoney.com. And this is for the SuperTry Grab Bag Jam. So if you're interested in making a game, our jam's going on for at least another month and a half. If you'd like to take a couple hours out of your month to make something cool, you're welcome to join us. You can find that at jam.supertrystudios.com. Thanks again for watching, and I hope everything goes well for you. Goodbye.